Hello, and welcome back to another How to Math. Today we'll be looking at applications of sine law and cosine law. So, essentially the sine law is using proportions of a triangle. So when side length A over side length, or over sine angle A is equal to side length B over sine angle B. So when we look at a triangle, actually this would be better to look at for demonstration purposes. So we have A, B, A, B, and C. Then we have opposite, which is A, opposite, which is C, and opposite, which is lowercase b. So when we're given angle and the opposite side length, it'll be equal to the other opposite angle and side length within a triangle. Now when we're looking at cosine law, we use a cosine law when we either have all three side lengths, or if we have two side lengths and the angle measure in between those two sides. So when we look at cosine law, it'll be like this. So either we have all side lengths, or the typical would be if we have so we have C, we have A, and we have B. So typically what we would have to get is this, and we would have the A value and the B value, and then we would be trying to look for C. So that's typical applications of sine law and cosine law. Now let's look at some examples. Okay, so first we'll look at sine law. So I'll just draw. So we're finding theta for this triangle. So it'll be like this. It'll be around here, like so. We label. This is 120 degrees. This is theta. And we have side lengths 12.3 centimeters and 9.1 centimeters. So in order to find theta, we just use the sine law. So let's see. We'll sine 120 over 12.3 is equal to sine theta over 9.1. So when we rearrange, it'll be sine theta equals 9.1 times sine 120 over 12.3. Therefore, theta is equal to about, 9.1 times sine 120 divided by 12.3, and then inverse sine. That'll equal about 39.85 degrees. So that's how we use the sine law. We could do another example. This time it'll be a word problem. Okay, so we could do it over here. So a neighbor claims that their lot is triangular. One side is 430 meters, and the adjacent side is 110 meters. So we just draw this. Let's see. Okay, so we have one side, which is 430 meters. The adjacent side, which is 110 meters. And it says that the angle opposite one of the sides is 35 degrees. Determine the other side length of the lot to the nearest meter, as well as all interior angles to the nearest degree. So opposite one of the side lengths is 35 degrees. So this is it. So what we have to find is this. and also the other angle. So we could have like theta here, we could have beta here. Okay, so first we use the sine law in order to find out x. Actually, we can't find that out exactly yet. We have to find out the interior angle measures first. So we can find beta. So we do sine 35 over 430 meters is equal to sine beta over 110, which is equal to sine theta over x. So first we would look at this, rewrite for sine beta equals 110 times sine 35 over 430. Beta equals about, let's see, 110 times sine 35 over 430, and then inverse sine that. It'll be, beta will be about 8.44 degrees. So then using 8.44 degrees, we can actually find theta by doing 180 minus 35 minus 8.44, theta equals, so 180 minus 35 minus 8.44, so that'll be about 136.56 degrees. So okay, so now that we have that, we can actually solve for x. So sine 35 over 430 is equal to sine 136.56 over x. Therefore, x equals sine 136.56 divided by, divided by sine 35, and don't forget the times 430 over here. Therefore, when we evaluate, x equals about, let's see, okay, inverse sine 10 times sine 35. 1 second while I do these calculations. 1 minus 35, 36. Okay, so now we have 430 times sine 136.56 divided by sine 35, which equals about 515.45 meters. So therefore, the unknown side is 515.45 meters, and then the unknown interior angles are 8.44 degrees and 136.56 degrees. Alright, and now we can move on to maybe some cosine law applications. So I think we can erase this now. Yeah, if you guys need more guidance in terms of sine law, you can always rewind and look back at the video. But now we'll be moving on to cosine law applications. Okay, so we have that out of the way. Let's do these examples. So find the unknown angle. I'll draw a couple triangles so we could have this diagram this triangle. So let's say this is A, B, C, and we have 5 centimeters, 8 centimeters, and 10 centimeters. So we have all three angle measure. We have all three side lengths, meaning that we can use this formula, this version of the cosine law, in order to determine unknown side lengths. Then after we find an unknown side length, we can use the sine law actually to find the other unknown angle measures. So first things first, we plug this in. Let's say we're finding angle measure C, just to keep it as accurate as possible. So we have A squared. So that'll be 10 squared plus 5 squared minus 8 squared divided by 2AB. So this would equal, 100 plus 25 minus 64, which equals 61, over 20 times 5, which is 100. So this angle measure would be equal to it would be equal to 0.61. Now remember, all of this is actually equal to cosine C. We can move this down since we don't have room. Cosine C is equal to 0.61. Therefore, C is equal to about 52.41 degrees. Now we can use the sine law to find the other unknown angles. Let's see. Okay, so we could do sine 52.41 over 8 is equal to sine A over 10 is equal to sine B over 5. So for sine A, let's see, sine A equals 10 times sine 52.41 over 8, in which angle A equals, let's see, inverse sine, 10 times sine 52.41 over 8 should equal about 82.10 degrees. And then for sine B, the same thing, is equal to 5 times sine, so 5 times, we can do sine 82.10 degrees over 10. Therefore, B equals about, let's see, so we have inverse sine, 5 times sine 82.10 divided by 10, which is equal to about 29.69 degrees. So therefore, the unknown angle measures are 82.10 degrees, 29.69 degrees, and 52.41 degrees. So that is an example of applications of cosine law. Now we can move on to another one, which is a slightly different case. In the example I will show you, this case, we will have two known sides and the known angle measure in between those two sides. Okay, let's draw this out real quick for you guys. So we have this, and we have this. Okay, so we have okay, so this is actually a word problem. I'll just draw out the diagram for you guys. And okay, so this is regarding golfing. So Gabe hits a shot from T towards a hole at H, but the ball veers 23 degrees and lands at B. So H is 270 meters from T, as we labeled. If Gabe walks 160 meters to the ball, so this means that the distance from T to B is 160 meters, as we stated right here. How far to the nearest meter is the ball from the hole? So we are trying to find BH. Well, we have two known sides and one known angle measure in between. So we can use the cosine law. So essentially, x squared is equal to 160 squared plus 270 squared minus 2 times 160 times 270 times cosine 23 degrees. So x squared is equal to, when we evaluate this, I'll do this real quick. 160 squared plus 270 squared minus 2 times 160 times 270 times cosine 23, which equals about 18968.38 meters. When you square root this, x equals about about 137.73 meters. When we round it to the nearest meter, distance from B, from the ball to the hole, is equal to about 138 meters. So there we have it, folks. That is, those are applications of sine law and cosine law in trigonometry. I hope this helps, and yeah, this is actually the end of the series, so thank you for listening, and I hope this has helped you on your journey through grade 11 functions.